Hello friends, today we'll see how to interface my Hall sensor with my Uno board. Before that, let me just tell you the different kind of Hall sensors that are available in market. Apart from this, there are many different Hall sensors, but I'll be putting light on these three sensors today. These are the different kind of Hall sensors that are available in the market. The first one is KY024 linear Hall magnetic sensor, which has AO as well as the DO pin in comparison with the other two Hall sensors, that is KY003 and KY035. Also, this linear Hall magnetic sensor 024 has a inbuilt onboard potentiometer which helps us to adjust the sensitivity. That means we can increase the sensitivity so that even if the magnet is at the long range, it can detect easily. So, whereas this feature is not available with the other two sensors KY003 and KY035. Also, in KY03, we can see an onboard LED as well as the resistor inbuilt, whereas in KY035, it does not have any onboard resistor as well as LED. It just have the Hall element that helps us to detect the magnetic field. Always remember that the magnetic field should be placed perpendicular to the Hall element in order to generate the voltage. Now, let us quickly see the working principle of the sensor. Basically, the Hall effect sensor works on the principle of the Hall effect, which states that whenever a magnetic field is applied in direction perpendicular to the flow of electric current in a conductor, a potential difference is induced. This voltage can be used to detect whether the sensor is in proximity of magnet or not. The Arduino can detect this voltage change through its interrupt pin and determine whether the magnet is near the sensor or not. The basic working of Arduino Hall effect sensor is shown in the picture here. Now we will see how does the AO and DO pins of the Hall effect sensor work. The basic Hall element of the Hall effect magnetic sensors mostly provide very small voltage of only few microvolts per Gauss. So therefore these devices are usually manufactured with built-in high gain amplifiers as shown in my figure number 1. Basically, there are two types of Hall effect sensors, one providing analog and other digital output. The analog sensor is composed of a voltage regulator, a Hall element and an amplifier, as shown in the figure number 1. From the circuit schematics, we can see that output of sensor is analog and proportional to the Hall element output or the magnetic field strength. These types of sensors are suitable and are used for measuring proximity because of continuous linear output. You can see clearly in the figure number 2 that my output, analog output, is directly proportional to the strength of the magnetic field, and above a certain value it reaches to a saturation level. Coming to the figure number 3, you can see on the other hand the digital output sensors provide just two output states, either on or off. We have seen that analog output provides a constant output voltage, whereas the digital output Hall sensors provide only two states, on or off. These types of sensors have an additional element as illustrated in the figure number 3, that is your schematic trigger, that provides hysterics, or we can say that schematic trigger provides two different threshold levels so that output is either high or low. For more to get about the schematic trigger, you can refer Wikipedia. Now let us quickly move to the pinout diagram. This is how I will be interfacing my Hall sensor KY024 with my Uno board. Here you can see that the DO pin and the AO pin are interfaced separately. In my case, in my demo, I'll be clubbing it together. That is, my digital pin will be connected to the pin number 2 and the AO pin will be connected to the analog pin A1 of the Uno board. That's it for the circuit diagram. Let us quickly move to the code. This is the code that I have uploaded to the Uno board in order to make my KY024 linear Hall magnetic sensor work. I'll be uploading the same code and will be showing you the demo in a minute. The circuit diagram for KY003, where you can use this sensor if you don't have the KY024, but I would prefer you to just see the specifications and see accordingly which suits your project or which suits your need. This will be the code that will be uploaded to this sensor in order to make it work. Coming to some of the applications of the Hall sensor, basically one of the main important application of Hall effect sensors are used for proximity switching, positioning, speed detection and current sensing applications. Also, they are used in brushless DC electric motors to detect the position of the permanent magnet. And you can read the other applications. Now let us quickly move to following are the websites that I have referred to in order to get to know about the Hall sensor and its working. You can also go through them, and there are also many other websites that will help you to understand the working of the Hall principle. That's it for the theory part. Now let us quickly move to the demo.
It's time for the demo. You can see I have two types of Hall sensors here. This is a KY024 Hall sensor, whereas this is a KY003 Hall sensor, which does not have any onboard resistors on it, neither a potentiometer that will help us to adjust the sensitivity. I will prefer this and will be showing you demo with this KY024 linear Hall magnetic. This is how we'll be interfacing my Hall sensor with the Uno board, where VCC and ground will be connected to VCC and ground, and analog pin will be connected to A0 and digital pin will be connected to pin number 2 of the Uno board, and LED is connected. Now we'll see, as soon as my Hall sensor detects the magnet, my LED will glow, and as earlier explained, for the metal touch sensor we can see only one onboard LED glowing. As soon as it detects the second magnetic field, the second onboard LED will also glow. We'll keep the magnetic field perpendicular to the Hall sensor. As you can see, my second onboard LED is also glowing, and also my LED is glowing here. And we can also see it on the analog screen how the value is getting changed. The analog readings on the serial monitor as above 500 or 530, but now as soon as I bring my magnet near the Hall sensor, you will see my analog reading getting decreased. That is, they have decreased below 500, but this value will keep on increasing, indicating that my A0, that is the analog output, is directly proportional to the external magnetic field applied. Thus, this is how the Hall sensor works. That's it for this video. Thank you, friends.